o'clock on Tuesday. Is this the theROMKids show? Hello everyone, we are here, we are excited. Long-time viewers of the show will know that we're in the process of moving, so this is our 4th episode in a different house. Today is also really exciting because it is the season finale of the theROMKids show. That's so exciting. We've done 41 episodes, covering everything from dinosaurs to water equity to perseverance. Today is our 2nd episode all about whales because I know you're so excited that this summer, increasingly, it's looking likely that we will be able to open our blue whale exhibit, our great whales exhibit, up close and personal. So we thought with our final episode of the season that we would talk to you with Mammalogist Burton Lim, who's a curator on the exhibit. He's our resident Batman because he studies bats, but he studies all mammals too. So small mammals and of course the largest mammal and animal of all time. So we're really excited to do that. Last week on the show we had an amazing episode with Craig Cipolla. He's an archaeologist at the ROM, and we were talking all about what archaeology is. I'm sure some of you participated in our grape experiment. I hope that's going really well for you. I've had so much fun over the last year doing this distance learning, this museum distance learning with you, introducing you or reintroducing you to all of my favorite ROM friends, scientists, technicians, everyone under the sun at the ROM, talking to you about the really cool work, exploring our collections and research. We've covered things as they were happening, trying to make sense of this complex world, and we've all got to do it, from our kitchens, from our living rooms, from our classrooms, from our virtual classrooms on YouTube and live. So thank you so much for joining us. This has been an incredible experience for me. So hello to everyone at home, hello to everyone in your virtual schools, and I think with that we are now ready for the theme song portion of the event. Last one of the season. Whoa, here we go. Welcome to the theROMKids show with me. We'll do some crafts and tell some stories. Let's talk about science, art, and history. Welcome to the theROMKids show, starring you. There we go. Yeah, this is our 4th episode with a live audience. Feels so great. Colbert went live last night with an audience, but we've been doing it for a month. Safely, securely, and I feel good about that. Time to move over to the art table. Whoa, just like that, a lot easier than at home. Okay, so today we are talking about whales. And to do so, we're going to do a science experiment a little bit later on. And we're also going to make these silhouette whales, okay? So imagine you're underwater, like so far underwater that the whale is swimming over top of you and the sun is high in the sky. You're going to see the dark silhouette of a whale right above you. So we're going to do some art. We're going to learn an art technique as well today with blending some chalk. So with that in mind, what do you need? Well, you need a black piece of paper for your backdrop, and you need a second black piece of paper to make your silhouette, okay? Then you're going to need a white pencil so you can draw on your black paper, and then you need a variety of chalks. Today I'm green, white, purple. If you have black chalk, like we don't, but if you do, that'd be super cool. To do your mixing, and again, a light pencil to do your work. And then finally, glue and scissors to complete your masterpiece. And with that in mind, I'm also using a little bit of like a drop sheet here so I don't get dust everywhere. Okay, today, recap of supplies. I know we have a weird internet connection here. Recap of supplies is you need your black construction paper. If you can have 2 pieces, that's great. You then need a light colored pencil crayon so that you can draw your whale silhouette. You need chalk so that you can make your background. You need scissors and glue to cut out your silhouette. And then you can blend with your hand or you can blend with like some tissue paper right there, okay? Those are the supplies. Please go grab them. And remember, halfway through, we're going to do a demonstration as well. But time to introduce my good friend Burton Lim. Let's do that. Hello, Burton. How you doing?
There we go. Good. How's everybody out there?
Oh, we're so excited to have you here. If you go on YouTube, you can find our first episode with Burton. It was all about bats and, you know, a lot of the science and the misinformation that's going on right now. So it was so cool having Burton on then. I'm just going to turn the brightness down just a little bit so we feel good. Okay, Burton, we're going to talk about whales, but I'm going to do my first step with my audience first, with my friends at home and at school. What I want you to do is draw on your black piece of paper a silhouette of a whale. So I've already cut mine out, but again, what you can do is like look up a picture of a whale and then with your light colored pencil, draw it on your black paper, okay? I have yellow here, a white pencil crayon would work as well. Get to that. Okay, Burton, we have a new exhibit coming to the ROM this summer, Great Whales Up Close and Personal. You, along with a great team of staff, have been putting it together. You excited?
Really excited. It's been a long 1+ year, especially during the COVID, but really excited to see it on display and to get everybody else to see it in person too.
So today, to get you excited, we're going to talk about the science of whales because they are incredible, incredible animals, all right? So the evolution of whales is a little bit interesting. But first, let's start with this. Burton, what makes a whale a whale? Because a whale is not a fish. A whale is a whale.
Yes, a whale is a mammal, but unlike most other mammals, it obviously lives in the ocean, so it has a lot of sort of adaptations that make it able to live in the ocean, such as a streamlined body. It has flippers, not arms or front legs. The hind legs basically have disappeared. You don't see them on the outside of the body. But obviously they breathe like mammals and they need to breathe air. So they need to come up and breathe through a blowhole on top of their head, like a nostril. So they have all of these different features that allows them to live in the ocean full time.
Okay, that's really interesting. I want to get back to that ocean connection in a second. But there's an animal today that is related to whales, but doesn't really look like one. What's the hippo connection to whales?
Well, the hippo is the closest living relative to whales. So that's a bit surprising to most people. It was surprising to me when scientists first started proposing this. But that is based on evidence from not only the DNA, genetic information, but also from the fossil record, and also looking at anatomical features. So there's at least 3 different, main groups of evidence that say that hippos are the closest living relative to whales.
That's fascinating. So essentially, if you go far enough back in time, hippos and whales had they evolved from one animal and then went their separate ways. As Burton, though, before we were talking in our interview, there are animals that are more closely related to whales in the fossil record. They've just gone extinct. So the closest living relative of whales are hippos, which I find so fascinating that, Africa's most deadly animal, the whale, is also the closest living relative to the largest animals, to a number of the largest animals to ever exist on Earth. Okay, so why would an animal that was on land go back to live in water, not even just like semi-permanently like a hippo, which is on land and in water, but to live in water permanently? Like, what's up with that?
Well, it was a gradual thing. So, like some of the oldest fossil whales go back, like 55 million years ago. So it didn't happen like overnight or anything like that. It was just a gradual sort of change and evolution. Yeah, so the original fossil whales, they were terrestrial, lived on land, but they they were feeding in the water, but just over time, millions of years, they just accumulated different adaptations. They evolved these adaptations that allowed them to live, permanently in the ocean. So it took a lot of time, but just gradual changes that just made them a little bit more adapted, a little bit more easier for them to live in the ocean.
That's really fascinating, and I think often, like, maybe it's food. It just loves the food in the ocean so much. First it's a turf animal, then it's a surf and turf animal, and then it decides I'm surf only. Okay, now I'm at this point. I'm sure you're done with your silhouette. So what I want you to do is we're going to do a gradient here, where we're going to start with these lightest colors in the middle, and then go darker as we come out. Okay, and that's going to represent the sun high above the ocean. It's noon. That sun is high in the sky, beating straight down. So I'm going to start with white in the middle and get darker as we go out. Okay. Now there's a word that I've heard, Burton. I was wondering if you can explain it because it involves whales. Let me know if I'm saying it right. Vestigial? What does that mean, and how does that apply to whales?
Well, vestigial just means it's like a remnant, something that is left over or remaining. So that goes back again to the evolution of whales. So again, the whales' ancestors lived on land, but as part of the adaptation to living in water, they didn't need hind legs anymore because they were swimming in the water to the point where all of the modern whales we see today, you don't see any hind legs on the outside of the body. But when you look inside, the anatomy, the skeleton, there are, remnants of hip bones. The odd time you might see some leg bones in there. But basically, they've shrunk to the point where they have almost disappeared, but they're still there. So that just is evidence that they did have a terrestrial origin. So that's just evidence that you don't see unless you actually dissect a whale or you come to the ROM and see our exhibition, because all 3-year-old whales have these little bones, these hip bones that you can see at the exhibition.
Definitely check it out. During the first exhibit, when I saw the blue whale, which was one of the coolest things I've ever seen in the museum, there's just this like little bone hanging out in the back that just seems to be like, what is it doing? And so evolution is incredibly cool. It's a complex process, and as Burton is saying, it happens not overnight, not over the course of a summer or even a pandemic. No, it takes millions of years for animals to undergo evolution, okay? And in this case, tens of million years. The science of whales is fascinating. And so what I want to do is we're going to sort of break down whales here into toothed whales and baleen whales. Why did some whales evolve teeth, and why did some evolve baleen? And I guess we'll talk about baleen in a second, but what is the process here where some would go with teeth and some would go with baleen?
Well, with the whales, but just mammals in general, teeth is sort of what most mammals, most whales have. So baleen is sort of the unusual, the unique thing about whales and mammals in general, because whales are the only animals that have baleen. So baleen was a relatively recent evolution, but that still goes back like 30 or 35 million years ago. But it was just a different way for them to feed. So they were able to take advantage of the small organisms. So a lot of these krill or copepods, phytoplankton, they're small, but they are found in huge numbers. So whales that have baleen, they've taken advantage of this small but abundant food source to feed on them.
That's fascinating. So toothed whales are going after fish and squid, so animals that are a little bit bigger, and the baleen whales are going after some of the smallest animals in the ocean. You can see right here, here's a guy holding up a little vial, and in the vial it's a bunch of krill. And that's what baleen whales are trying to eat. These giant animals, like the blue whale, it eats tiny, tiny, tiny little animals like krill right here. Can you imagine that? Like, we eat a variety of food, but that's sort of like, I'm going to equate this to sort of if we lived off of just eating ants, you know, when it comes to size. Oh, we have a great question from the group chat, Burton. What is baleen made of?
Baleen is made out of keratin, so it's the same material that you would find in your fingernails, but also your hair, or also in hoofed animals. So the keratin is just the hard substance. So baleen is actually relatively hard, so it's a little bit pliable when the animal is alive, but when it dries out, it gets hard. But it's almost like a plate that sort of looks like Venetian, vertical blinds. So basically, these plates hang in a vertical blind inside the mouth of the whale, and that's how it filters out its food, whether it's krill or copepods.
Okay, we're about to do a demonstration, but we have a question from the group chat from one of our friends, and they want to know about breathing. Syed wants to know, how do whales breathe? Because they're not fish, so they don't breathe underwater. How do they breathe?
Well, they breathe like you and me. They need to breathe air, but obviously living in water, they need to dive. So whales are a little bit better than us, a lot better than us holding their breath. Blue whales, they can probably hold their breath, up to about half an hour. Sperm whales, so we have a sperm whale skeleton in our exhibition. They can hold their breath for over an hour, so they can dive a lot deeper. But the world record holder for whales is a species of beaked whale, Cuvier's beaked whale. And I think it has held its breath for over 3 hours.
What?
During a dive. Just imagine you trying to do that.
I can't. Okay, now let's bring this back to another episode we did. We had Sebastian on, and we were talking about how deep the ocean goes. And we learned on the show, you can find it up on YouTube, that the deeper you go, the more pressure there is on your lungs, which sort of makes your lungs smaller and smaller over time and harder to hold your breath. So when you think about these whales, even at 30 minutes, they're holding their breath for 30 minutes, diving really deep under the pressure of the ocean, and they're still able to, go hunt, live, do their business. So that's really interesting. Okay, we have another question from the group chat, and if you can just flip that up. Okay. So when whales breathe, right? It's not like us where our noses are in front of our face. Their nose is on top of their head, so that they just have to go up to the surface, breach the surface a bit, open up those nose holes, breathe, close them, and then go back underwater. Yeah, there you go. So that's...
Yep.
Okay, we have another question from the group chat, and then we'll do our demonstration. How do whales sleep? Do they sleep?
Whales do sleep, and there's still a lot to be learned, but some whales have what's called a unihemispheric sleep, so half the brain basically shuts off, but the other half stays alert. So this way they can make sure that if any ships come nearby, that they're alert enough that they can wake up and move. So they basically rest half of their brain at a time, and this is how they get a full sleep, by resting half the brain at a time.
Wow, that sounds awesome. I wish I could do that. I often feel like I don't have enough sleep and just want to take a little nap during the day, but I still got to work, or I have to walk, or I have to do something. So maybe I should grow that type of brain. We are going to do a demonstration now to explain how baleen works. If you want to do this demonstration with us, what I want you to do is I want you to grab 2 containers of water, some pepper, some ground pepper, and then a comb or 2. The tighter the comb you have, the better. Okay, so Burton, what I'm going to do here is I'm going to describe to you what I'm doing, and then you can fill in the gaps. Because there's some science going on, and I want to make sure we do it right. So we're going to talk about how toothed whales find their prey in a moment. But with our baleen whales, they're looking for these giant pods of krill, okay? So what I want you to do is to simulate the krill in your one container with water. I want you to grind up some pepper, all right? This is symbolizing all of those tiny little krill, those tiny little animals that baleen whales eat. Because again, these giant animals are not eating fish or squid. They're eating tiny animals, all right? So there you go. There is my pepper. Now, Burton, what I have here is another container, all right? And I have two combs that I'm overlapping with each other, okay? And I'm going to put it over top of my one container right here. Now, can you explain to us, before we do this demonstration, how a blue whale gets all that water in and then how it filters the krill?
Well, the whales, they start off by opening their mouths. They get a big mouthful of seawater with the krill inside of the food.
Whoa, we're not running out of time.
And then it closes its mouth, and then it uses its tongue to push the water out through the baleen. So basically, the baleen acts as a sieve that catches all of the food on the inside of the mouth as the water goes out, and then they use the tongue to sort of guide the food back into its throat so it can swallow the food inside its mouth.
Awesome. Okay, so with that in mind, this is our whale full of all of this pepper. It's taken in all of that water with the krill in it. Now it's going to, with its tongue, it's going to push the water through the baleen. And what's that baleen going to do? It's going to hold on to all that krill. So let's see how this works. Now, in our demo, it didn't work too well, so let's try now. Oh, okay. So you can see some of the krill is breaking through, but I'm going to show you in a second. The tighter you have of a comb, the better this works. But again, this is me pushing all that water out of my mouth, because I'm a whale, a baleen whale, through the baleen, and then the baleen holds on to the krill. So let's see if we can take a look. How did our demonstration go? It went sort of okay. You can see a bunch of it right up at the top. Okay, you see all that krill? This is not real krill, but you see all that pepper there? That's the comb, that's the baleen capturing that food. Isn't that fascinating? That's not at all how we eat in any way, shape, or form because we use teeth. So there you go. What a fascinating way that this giant animal found to survive. Now, Burton, because of our little issue earlier today that was on my end, what we're both going to do is we're going to leave the Zoom and come back into the Zoom, okay? Because it thinks that we're more than one person, all right? See you soon, Burton.
Okay, see you in a bit.
There we go. Okay, fun things when you use Zoom. Let's log back in because we still need to talk a little bit more about how toothed whales find their food because a fascinating way that they go about it. So I hope that your drawing is coming along, all right? Make sure that you make those rings. I'm now going to add my blue ring, which I'm really excited about. And then that's going to work together. Again, we're talking about whales today. We got Burton Lim on. We're so excited because this summer at the Royal Ontario Museum, we have a brand new exhibit called Great Whales Up Close and Personal. And you're going to be able to get up close with a blue whale, a sperm whale, and then what's the right whale that people get to see?
That is the North Atlantic right whale. So that's one of three species of right whales that are found in the oceans. So the North Atlantic right whale is the one that we have.
Big animals, I like it. Okay, so we just did our demonstration on that. Now I want to talk about how toothed whales eat because they use sound. Oh, sorry, we have a question. Oh, we have, how do whales communicate? Okay, so here, this is where we are. Great question from the group chat. Let's first talk about how whales eat, and then we'll get to communication, okay? So, Burton, toothed whales. how do they use sound to find their prey?
Well, toothed whales, including the sperm whale, they use higher frequency echolocation. So these are sounds that, in general, most of these sounds are so high that we can't hear them ourselves. Sperm whales are a little bit different is that their echolocation calls, some are high frequencies that we can't hear, but also some are lower that we can hear. But it's these high frequency calls that are fine enough that they can pick up like a squid or fish that are swimming around in the ocean. So they use the echolocation. So basically they'll send out like a general pulse or a call, and it finds something that might be fish. So they hear an echo come back, they'll swim towards it, and as they get closer to it, they send out more calls, more clicks, to get more finer detail of where the food is. So that's how it uses echolocation to zero in on its food prey.
Okay, so we're gonna try and show you what that sounds like. This is a sperm whale trying to search for its prey. All right, it's just these little pulses that go out. Now, pay close attention. This is what it sounds like when it's homing in on that prey. So that sperm whale, it's sending out those slow clicks. It's finally found some sort of maybe a squid that it thinks is super tasty. So now it knows where it is, and this is what it's going to do with its high frequencies as they get faster. There you go. Wow. I really like that when I first heard it. So, it gets faster and faster and faster as it tries to locate its prey. And so that's really interesting. Now, you're a bat guy, Rom's resident Batman. Do toothed whales use echolocation in the same way that bats use echolocation?
Yeah, in general, it's the same sort of method or technique. So it works both in the air and also in the water, but essentially it's the same way of finding food. Whether it's insects or whether it is fish or squid in the water.
That's so cool how like two very different, animal groups, got flying mammals and like our swimming animals, they both use echolocation. So going back to our question from the group chat, how do whales communicate? I guess they use sound as well?
Yeah, so the sounds, so the communication is usually the lower frequencies, so not the higher echolocation frequencies. But baleen whales use primarily what's called infrasonic. So these calls so low that we can't hear them either. Okay. So not only do the echolocating whales produce too high calls that we can't hear, but now these are too low. These calls are too low in frequency that we can't hear them. But the low calls, they travel further in the water. And blue whales are known to communicate with other blue whales like up to 1,000 kilometers away. So that's pretty mind-boggling.
What?
So when people think that, this is a whale by itself, it might be talking to another whale hundreds of kilometers away.
That's wild. Like I can be talking to my friends like right next to me and they can't hear me. Okay, so what we have here is a humpback whale song. And we have some more questions from the chat that we're going to get to in a second. But this is a humpback whale song brought to us by Monterey Bay Aquarium Research Institute. I hope you can hear that. That's a really interesting sound. To me, it sounds sort of like a violin underwater. I'm not sure if anyone else is hearing that. If you are, throw a violin in the group chat right there. So what is this humpback whale communicating? Do we know? What is it doing here?
I have no idea. I think it is using it. It might be saying something as basic as, just telling other humpback whales that, hey, I'm over here. And, where are you? And then the other humpbacks will, give out their call, to tell, the rest of the whales, where everybody is. So just how's it going? Just checking other people out.
That's fascinating. So high pitch frequencies are used by toothed whales to search out prey for dinner, and low frequency sounds are used by most whales, all whales, to communicate.
Primarily the baleen whales, but sperm whales, toothed whales do have lower sounds, but the baleen whales are more noted for their infrasonic sounds, the real low ones, and a lot of those we can't hear.
Got it. Okay, now one final question about sound, and then I think there's a chat that I have to answer here. I understand that one of the loudest sounds made by an animal comes from a whale. Is that true?
Yeah, it comes from a sperm whale, and it's sort of the sound. It's like, not that I've heard dynamite go off, but it is as loud as dynamite exploding. So that sounds loud to me.
So dynamite, that's an explosive. A sperm whale is as loud as an explosive device. There you go. That's fascinating, and that is science. Okay, I think we have a question from the chat that I want to answer. Okay, why are whales such great swimmers?
Well, it's a lot of the adaptations on why they ended up, evolving as marine mammals. So I mentioned the streamlined body. So this way, less drag swimming in the water. They've got a tail. They have a tail fluke, like the big flipper, but it's horizontal, so it's different from a fish, which is vertical. So the whale tail will actually go sideways, a fish does. So whales have come up with a way of swimming efficiently in the water. So of course they don't have front legs, but they have flippers. So a whole bunch of different adaptations just make them good swimmers.
That's evolution, and that's what happens over tens of millions of years. Okay, my final question from the science section that I want to ask you is one that's fun for our audience, because we are interested in this. Is it true, and why, if so, that whale poop is good for the environment?
Yes, in general, whale poop is good for the environment. There's still a lot of studies going on. But basically, a lot of the whales, they will eat, further down in the lower depths of the water. And in general, whales, they poop near the surface of the water. So basically, they are recycling these nutrients from the bottom of the ocean to the top of the ocean. And of course, a lot of poop. And when they die, if they don't get eaten, if they die, they sink to the bottom of the ocean. So this way, they actually bring carbon down into the depths of the ocean. So it's this whole cycling effect. That whales are one of the primary, supporters or things that keeps this whale pump going.
The world is full of cycles. Whale poop is a cycle. The water cycle is a cycle. There are so many different cycles that make our environment and planet operate. Okay, now we have a question from the chat, but I want to do the next step. You can use your finger, or you can use, this is just a Kleenex. And then what I want you to do is smooth out and blend the chalk together, so it gives you sort of that underwatery effect of seeing the light above you. Okay, now Burton, this is a fact-checking question. Not sure if you know this. How fast can whales swim?
That is a very good question.
Come to the exhibit this summer. Go ahead.
I missed that part, but I'm guessing they can probably swim probably at least 20 kilometers an hour.
So there you go. Lots that we still are learning.
And people can fact check me on that one.
Yeah, fact check, go Google it. But an interesting thing to know is that because whales are so, they're in the ocean, which is a giant space, there's lots of things that we're still learning about whales. So if you go on to work in oceans or mammalogy or in science one day, these are answers that you yourself can start to figure out too. Now, whales are really big, but there still are some threats. Whales are threatened by whaling, which was the hunting of whaling that took place. Why would people, Burton, hunt whales?
Well, in the beginning, it was just, for subsistence, for the people's survival. They were just looking for food. So, this is going back, thousands of years that, people would be looking for food. Some people that, lived inland, they would hunt, obviously, terrestrial animals, deer or whatever. But those that lived on the coast, they would take advantage with whatever, food sources were around. And some of them happened to be whales. So they would use it to feed themselves and their families.
There you go. And, it's all about being responsible about the things that we do. And ultimately, society as a whole was not responsible in hunting whales, which brought them very close to extinction. There's not as much whaling that goes on today, but there still are threats from propellers to sound. But Burton, I learned from you that one of the biggest threats facing whales are entanglements. What are entanglements?
Well, there are fishing gear, fishing lines that are out there. There are nets that are out there. And over time, there's some of this, the ropes break off or the nets break off, and they just end up floating around the ocean. And sometimes the whales get tangled up in these fishing lines or these nets to the point where they're struggling. So it may not kill them directly, but it may just make diving that much more difficult. So it makes them it makes it more difficult for them. One of the more recent threats, as more and more fishing gear and nets, get out there, get abandoned.
There you go. So, it's really important that when we bring things places, whether it's into a forest or a park, or, especially into the ocean, that, we don't leave stuff there, okay? We don't want our plastics from our homes making it there, and we don't want to leave nets out in the oceans either, because wildlife can get caught up in them, can mistake them for food, but ultimately threaten their lives. Okay, so Burton, closing this up, wrapping this up, what can we do at home to help our whales? Because so many of them are threatened.
Well, there's a lot of things we can do from home. So you don't have to live, by the ocean to help whales. So people that live in Toronto, they can do research to find out a little bit more about, say the organizations that help protect whales. They can also, just make sure, as you mentioned, not to pollute our water. So don't try to minimize, the amounts of chemicals that get into the water system, because eventually, putting stuff into the rivers in Toronto, they'll get into Lake Ontario, they'll get in the Gulf of St. Lawrence and in the oceans worldwide. So just to be conscious about, what, we throw away, just to minimize the amount of garbage and chemicals that we put into the environment.
I like that. We spent a lot of time talking about keeping our water clean. And so that's by, recycling what you have, limiting how much plastic and materials that you do buy. And of course, because we are that progressive show, get involved with local organizations and community organizations, and even, you know, local community leaders, and ask them to prioritize our oceans and making sure that we keep our animals safe. Burton, Great Whales Up Close and Personal opens this summer. What is the thing in that exhibit that you can't wait for people to see?
Well, I'm going to go with the obvious answer and say we've got these 3 amazing skeletons for people to see right up close. So, you know, they'll be, you know, at eye level that you can see them. So not hanging from the ceiling or something. So I think people will be really amazed at, you know, the size of these animals. But they also get up close and look at them. You know, they'll be able to find those hip bones that we talked about, or be able to look more closely at teeth of the baleen. So I think the skeletons are the obvious stars of the show.
There you go. I really like that. Up close and personal, we really mean it. Here's my silhouette. I hope yours really turned out too. Remember, folks, this was the season finale of the ROMKids show. It's been, hey, there you go. Thanks, guys. Yeah, hey. Nice. This is fun. The season finale of the show. All of these episodes are up on YouTube. There's like 41 of them up there. I hope that you watch them. The plan right now is to return later once the school year starts up again in September, because we have some other things that we're going to be doing at the museum this summer. So, you know, definitely watch us on YouTube if you missed any episodes. Our other episode that we did with Burton, all about bats and misinformation, is up there. It's really cool. And we're planning on returning in September. There is a small likelihood of a 1-month short season this summer, but we'll find out on there. You'll always be able to find out on ROM Toronto Social. With that, thank you so much for inviting us into your household, for letting us bring the museum to you, for talking about our collections and research. Cool people like Burton, being able to chat with you about all the exciting things we do at the museum. Thank you, classroom teachers who stuck with us. Thank you to parents and grandparents and trusted adults who trusted us to talk to you about science, art, and history. And with that, this is the ROMKids show. It's with you, and it's with me. Thanks, everyone. Stay safe. We love you. Wear a mask. Bye, friends.